This is Calculus with Allenson, and right now we're going to be doing the 2003 problem number 1 from the BC test, Form B. What we've got here is two functions, f of x and a line y equals 18 minus 3x, and f of x is equal to 4x squared minus x cubed. And the first part, A, says to show that the line here is actually tangent to the graph of f of x at this point right here, and they say at x equals 3. So first of all, if that's true, then the slope of the curve should be -3 at 3. So let's try that. F prime of x is equal to 8x minus 3x squared. And so I'll do f prime of 3 and plug that in, and I'll find out that f prime of 3 is in fact -3, which is the slope here. So it does have the correct slope here at that point. Now we need to show that this line is in fact, or this is in fact the equation of that line there. And so I need to find the actual point where they meet. And so 3 plugged into f of x is 9. So I have a slope of -3 and a 0.39. So the equation of the tangent line there would be y equals -3 times x minus 3 plus 9. If I multiply this out, I get -3x plus 9, or -3x plus 18, which is exactly what we had here. So that shows that this is in fact a tangent line to f of x at x equals 3. The second part, part B, says to find the area of S. Simply the area of S right here. So we have two parts to deal with in this, because from 3 to here there's two functions you have to subtract, and so you actually have to go like this and take an integral. Also, you have to know this place where the intercept is, right here. So we're going to have to use our calculator and find out where the line intersects the x-axis, and that's going to happen at x equals 4. You can use your calculator to figure that out, because this is a calculator problem. So we're going to take the integral from 3 to 4 of the function on the top, which is 18 minus 3x, minus the function on the bottom, which is 4x squared minus x cubed dx. And then we're going to have to add on this triangular area right here, which is 1/2 times 2, this is 6, times the height here, and at 4, the height of that is going to be plugged 4 into this equation, so that would be 18 minus 12, or 6. So plug that in. There's also another couple ways you can break this down into parts, but this is just one way, and you should get 7.916 or 7.917. The last thing that you're asked to do is to find the volume of region R revolved around the x-axis. So that's going to look like this. Each cross-section is a circle with radius from the x-axis to the line f of x. So you're going to go pi times the integral from 0 to 4, where it hits, of the radius squared dx. That should get you 490.208. So on this problem, there are 3 points that you get for this last part. One for the limits, one for the answer, and one for having pi times 4x squared minus x cubed squared. For B, which I for some reason called A, you get 1 point for the answer, 1 point for the limits of integration, 1 point for what's written here, the integrand, and 1 point for the triangular region. For A, you get 1 point for finding f prime of 3 and f of 3, and 1 point for showing that it's the same line, or that this point lies on both lines.